Hello, my name is Chen. Today I'm presenting a temporally coherent video segmentation of echocardiography. As a common modality, echocardiography was one of the most widely used cardiac imaging techniques in clinical practice. The annotations in echocardiography allow clinicians to derive the important clinical indices, such as ejection fractions, for diagnosing cardiovascular disease. The manual annotations are time-consuming and suffer high inter-region variability. Thus, the automatic segmentation using convolutional neural network has been largely leveraged in this process. In this work, we implemented a recently published video segmentation network that produces temporally coherent video segmentation that improves the EF estimation on curated datasets. The network class proposed we et al. Takes in a 10-frame n-diastolic to n-systolic video clips and outputs multi-structural segmentation and bidirectional motion estimation for all frames. As you can see in the figure above, the control of the segmented left ventricular endocardium is marked in yellow, epicardium is marked in purple, and the control of the segmented left atrium is marked in blue. We compare the class video segmentation with the previous state-of-art frame segmentation on 450 patients in CHEMOS datasets, using the same tenfold cross-validation experiments. We applied data augmentation in training for both networks. The augmented A-class method, A-class, achieved consistent depth scores on segmenting key cardiac structures, but it significantly improved estimation on n-diastolic volume, n-systolic volume, and ejection fractions. Compared with the frame segmentation method, video segmentation achieves smaller mean absolute error in estimating EDV, ESV, and ejection fractions. On the right, it is a blunt ultimate plot of the difference between the automatic and clinical reported ejection fractions. The video segmentation A-class method attains smaller limits of agreement compared to the human experts as well. We additionally generalized the CHEMOS trained A-class method to a larger unseen datasets, clinical datasets, without tuning any parameters. Clinical echocardiography may contain multiple habits. As a test implementation, we use average-derived EF from all identified ED-ES half habits as a final estimation for the patients. Over the 1,274 test patients of the clinical datasets, A-class achieved the same depth score on segmentation compared with the frame segmentation, but on EF estimation, A-class obtained smaller biases and limits agreements and a higher close correlation compared with the frame segmentation. Video segmentation considers temporal consistency of cardiac motion in addition to spatial features when segmenting an echocardiography. It thus improved the estimation on EDV, ESV, and ejection fractions. We will generalize the CHEMOS trained A-class to a larger unseen clinical datasets without tuning, confirming the reliability of this method.